visiting Pathshala.com. In today's lecture, we are going to discuss about acids, bases, and alkali. So, what are acids? How do we face them? How are we acknowledged to them? Where do we find acid? So, for most people, acids are these corrosive, these violent, explosive chemicals that can harm us. That if we ingest it or even falls on our skin, it can burn our skin. You have seen acid survivors on whose faces acids were thrown by some perpetrator, and then you have seen damages done by different acids. But not all acids are harmful. Not all acids are that corrosive, that can cause that level of damage. Mostly acids are divided according to their strength. Some are weak acids and some are strong acids. Guys, if all acids were that harmful or that corrosive, then we wouldn't have been able to enjoy a lemon or an orange or anything sour for that matter. And also, if all acids were that big a deal in case of harming our body, then we wouldn't be able to enjoy a little bit of vinegar every now and then in our food. You see, these examples that I have given you right now of lemon and of oranges and that of vinegar, these contain acids as well. But these acids, they are really weak compared to those found in a car battery or that found in paint, etc., etc. So basically, those acids that are found naturally, that are found in the food we eat, those are known as weak acids or organic acids. And the acids that are manufactured by human beings, they are known as strong acids. Now, at this part of our lecture, we are going to discuss what weak acid and strong acids are and how they react with metals and different chemicals. So, without further ado, let's begin. So guys, as you can see here, this table contains the name of some very common acids. At this part, you can see some of the strong acids. At that part, you can see some of the weak acids. Okay, so like I said, acids are classified according to their strength. Some are considered weak, some are considered strong. So strength means how much or what level of corrosion an acid can pose. In case of strong acids, they are produced industrially for the very purpose of producing other useful products. For example, sulfuric acid is used in car batteries. Hydrochloric acid is used in paints, etc. Nitric acid is used to produce fertilizers. Now, when we shift our attention to weak acids, these are acids that are naturally found and also found in our food. For example, ethanoic acid is what is known as vinegar, and citric acid is found in all citrus food such as lemon, oranges, etc., etc., etc. So, the strong acids, we produce them for the very purpose of producing other useful products, and they are not naturally found. An example of a naturally found strong acid is what is present in our stomach. In our stomach, there is concentrated hydrochloric acid present, which helps digesting food by breaking it down. But even that is not secreted. Even that is not secreted up until food reaches into our stomach. So there is no natural way that hydrochloric acid is coming out of us, because if it did, we'd probably die. So hydrochloric acid is also industrially produced for other purposes, and these acids are naturally found. Now, why are acids important? They're mainly important because of their reactions, how they react with metals, how they react with carbonates, and etc., etc. And this is something that we are going to discuss via the help of equations right now. So guys, as you can see on your screen, that these are some of the chemical properties of acid represented by these equations. As you can see, at the very top of each equation is a word equation that depicts what exactly is going on, and on its bottom is a symbolic equation, a chemical equation that is representing in the form of chemical symbols exactly how the reaction is conducted. For your ease of understanding, I will explain them. In the first equation, we have metal plus acid equals salt plus hydrogen. Now, guys, for your ease of understanding, salt in this chapter doesn't strictly mean the salt we have in our food every day. That salt is what we know as sodium chloride, the salt, our table salt that we ingest. But in this chapter, salt means the product of an acid and a base, something we will discuss further in the topic salt at this very chapter. So, moving on to what we were discussing, metal plus acid equals salt and hydrogen. So, if we were to see in the form of a chemical reaction as how this thing is really happening, you see magnesium and hydrochloric acid is reacting with each other when you put them together in a reaction container, and it's producing magnesium chloride, which is a salt. So metal plus acid is forming a compound which we are calling, or which is known as a salt. So the salt here is magnesium chloride, and as a byproduct a gas is given off, and that gas is hydrogen gas. So the pin or the coin thing about reaction number 1 is that each time you react a metal with a strong acid, what you find is salt and hydrogen gas. So that was chemical property number 1. Next comes chemical property number 2, is that when you react a metal carbonate with an acid, what is produced is salt, carbon dioxide, and water. So, salt, carbon dioxide, and water. How does that happen? That is shown in the chemical equation below. So, calcium carbonate, which is also known as lime, and in Bengali it is known as chun, when it reacts with hydrochloric acid, it forms calcium chloride and carbon dioxide and water. In here, calcium chloride is the salt of the acid and the metal part of the carbonate. So, salt is any chemical which is a compound that has a metal part and a non-metal part. Like a metal part and a non-metal part from an acid. Combined together forms a compound which we know as salt. So calcium carbonate and hydrochloric acid is combining within each other, forming a white substance, a white solid, which is the salt in this reaction, which is known as calcium chloride, and is also forming bubbles of gas as a byproduct. And that gas is carbon dioxide, and it is also producing water, as we can see in this equation. And then comes chemical property number 3, which is very common when we are discussing acids and bases. This chemical property, which is also known as neutralization, it is important because this is something that happens inside our body as well. Like when we've had too much spicy or too much acidic stuff, then we feel uncomfortable, we feel gassy, we feel bloated, and then either doctors prescribe us or mom makes us something with ginger, and what that does is that it alleviates the excess acid formation inside our stomach. Now, when we take medicines for it, essentially what we're taking are bases. If you look at the chemical formula of any antacid, you will surely find that it is either a metal oxide or a metal hydroxide or sulfate. So what happens is that those chemicals react with the acid, and kind of alleviates the excessive formation of acid inside our stomach. So that reaction, where an acid completely reacts with a base, forming salt and water, is known as neutralization. And that is another important chemical property of an acid, as shown in this equation. So metal oxide and hydroxide plus metal oxide or metal hydroxide, not together, reacts with acid to form salt and water. And this reaction is known as neutralization reaction. As you can see in the chemical equation below, you have sodium hydroxide, which is a metal hydroxide, reacts with hydrochloric acid, forming sodium chloride, which is salt, our common table salt, and water. And down at the very last, you have an equation which is showing what happens when metal oxide reacts with an acid. So magnesium oxide is a metal oxide, and it reacts with sulfuric acid to form magnesium sulfate and water. So there you go. These are a few chemical properties of acid given to you in the form of word equation and chemical equation. Up next, we will be discussing a few other properties of acid. So as you can see in front of your screen right now, there are a few word equations and there are a few products that are formed. Why are these here? These are here to show you the importance of hydrogen ions and that of acids. Hydrogen ions are produced when acids are dissolved in water. And through these reactions, you can see how. See, citric acids, whenever they're dissolved in water, they form hydrogen ions and citrate ion. So hydrochloric acid, when dissolved in water, they form hydrogen ion and chloride ion. And as a result, sulfuric acid, when dissolved in water, also forms hydrogen ion and sulfate ions. Now, these can be represented in the form of chemical equations as well. So in the next part, that's what I will show. That is what I will show you in the form of examples. So guys, in here you can see two equations that show you how is it that hydrogen ions are released when acids are dissolved in water. So in case of sulfuric acid, when it is dissolved in water, hence the AQ or aqueous sign, it forms two hydrogen ion and sulfate ion. So a hydrogen is an element which has a symbol of H, and a hydrogen ion has a symbol of H plus, so it's an ion, which means it has it doesn't have all the electrons, and it has a loss of an electron, hence it has a positive charge. So moving on, whenever acids are dissolved in water, they form hydrogen ions. So sulfuric acid dissolved in water, and it's the aqueous sign, and forming two hydrogen ions and a sulfate ion. Similarly, when hydrochloric acid is dissolved in water, it forms one hydrogen ion and one chloride ion. So from these examples and from these equations, we can safely say that acids are chemicals which when dissolved in water forms hydrogen ions. So hydrogen ions, formation of hydrogen ion is an indicator of a chemical substance being an acid. If it's an acid, whenever it's dissolved in water, it's forming hydrogen ions. So how many hydrogen ions do you need for it to be an acid? Well, one is enough. But even then, there are acids that are classified into further groups such as monobasic, dibasic, tribasic, etc. Now, what do these words mean? Well, when we are talking about an acid that has only one hydrogen ion that can be released in water whenever it's reacting with water. See, the amount of hydrogen atom that is present in the acid converted to the hydrogen ion that can be released when it's dissolved in water. And that number is what's deciding either it's a monobasic acid or a dibasic acid, and so on and on and on. So if I were to explain what I just said via an example, see, hydrochloric acid is a monobasic acid. How did I reach to that conclusion? In hydrochloric acid, you see there is one atom of hydrogen. And this one atom of hydrogen is converted into a hydrogen ion, as was shown in the example a couple of minutes ago. That when this acid is reacting with water, it is forming a single hydrogen ion and chloride ion. So, since this acid is capable of forming one hydrogen ion per hydrogen atom present in itself, therefore it is known as a monobasic acid. You can also understand mono, di, or tri with the number of hydrogen atoms that are present in the equation, in the chemical equation of the acid itself. So, if I am to follow this example, then H2SO4 or sulfuric acid would then be a dibasic acid, of course, right? So H2SO4 then reacts with water to form two hydrogen ions. As a result, it's known as dibasic. And this, since it's forming only one, is known as monobasic. So, are monobasic and dibasic the only ones? No. Well, there is also tribasic. Example of a tribasic acid is phosphoric acid. Let me clean the word for you so you'll understand properly. So example of a tribasic acid is phosphoric acid, which has the formula H3PO4. So you see the number of hydrogen atoms present in this particular acid is 3. As a result, it can release up to 3 hydrogen ions per molecule of an acid. As a result, it's known as a tribasic acid. So, up next comes some of the uses, some of the importances of acid. Why? We have so far discussed what an acid is, some chemical properties of an acid, and then what exactly do we understand when we say a chemical is an acid. What is left is some of the uses or the industrial importances of acid. And this is something we are going to discuss in this part of our lecture. So guys, as you can see on the diagram on your screen, these are some of the uses of acid. Strong acids are used to make many important industrial products such as paint, detergent, etc., etc. The most important industrial acid is sulfuric acid. One of the other uses of acid is rust removal. Now, rust is a pesky brown formation on the top of a metal object, and it also deteriorates the structure and the smooth finishing of metal objects. Now, these rust can be removed via the help of acid. For example, a rusty knife can be cleaned with the help of a piece of lemon or star fruit. Something you might want to help telling your mom or your sister. But I can't really ensure that they're not going to beat you up for teaching them. Anyways, so a rusty knife can be cleaned with a piece of lemon or star fruit. Now, this is an important example of using an acid to clean rust. Rust is mainly hydrated iron trioxide, and when it is introduced with an acid, it reacts, and thereby it can be easily removed from the surface of the metal without further causing any more damage. And this same idea is used on a large scale in industry, where large iron and steel objects are dipped in an acid bath when they are to be removed, when rust is to be removed from their surface. And these are not the only uses of acid. Acids are also used to preserve fruits and vegetables, etc. For example, some vegetables can be preserved by dipping them inside ethanoic acid, which is vinegar. And in the same way, citric acid solutions and vinegar can be used to preserve other food as well. So these were, along with the diagram and my explanation, some of the few important uses of acids. So guys, so far we have discussed many things about acid. What acids are, what a strong acid is, what a weak acid is, uses of acids, chemical equations, etc., etc. Now, what do we understand when we say a strong acid or a weak acid? What is the strength of an acid? To understand the strength of an acid, we have to understand a term that is known as ionization. So ionization basically means forming ions. Whichever acid molecule, when reacted with water, can readily form hydrogen ion is supposedly considered a strong acid. For example, sulfuric acid, when reacts with water, forms 2 hydrogen ions and a sulfate ion. Therefore, all of the hydrogen atoms that are present in one acid molecule is converted into hydrogen ions. Therefore, it's ionizing completely. But that is not the case in terms of weak acid. Now, this phenomenon is explained much better in this diagram. As you can see, in strong acids, see, this is the key here, the key to understand the diagram. These circles represent acid molecules, and these represent the ions that are formed when acids react with water. So, when strong acid reacts with water, the acid molecules ionize completely, as in they convert into their following their respective ions, forming hydrogen and other non-metal negative ions, and therefore this ionization allows them to react much more efficiently than a weak acid molecule would do. Now, what a weak acid molecule does is, when it reacts with water, it ionizes very weakly or very loosely. See, so many acid molecules are left unreacted, and so less acid ions are produced. So, whenever an acid molecule is able to ionize completely, as in it, when reacts with water, gives up and forms ion much more efficiently than other acid molecules, it is known to be the strongest of acids. Example of strong acids are some that I have discussed at the beginning of this very lecture, such as sulfuric acid, nitric acid, and hydrochloric acid. So these were some of the example and explanation of what a strength of an acid means. So guys, this was the end of part 1 from the chapter Acid, Bases, and Salt. In part 1, we discussed mainly acid, acidic properties, chemical equations, uses of acids, etc., etc. In part 2, we will look deeper into bases, alkali, the pH scale, what indicators are. Now, if you have any questions about the part 1 of this lecture, please direct it to our comment section. If this video helps you understand the topics in chemistry better, please like and subscribe us. And up until the next part comes along, have a nice day.